Okay, so to continue is we have the last type for your transformation by trigonometric functions, which is your type C. And the format is the cotangent and cosecant pair up. So that's the integral of cotangent with an exponent of m, and then a cosecant with an exponent of n. So again, if you try to recall the specific Pythagorean equation or specific Pythagorean identity for this one is, if you can see here, so this one is just um, rearranged from the original equation, but from the derivation of your Pythagorean identity, so the formula is 1 plus cotangent squared theta is equal to cosecant squared theta. So if you try to rearrange that one, so this one is the equation. So still we have two cases for your type C, and we'll be discussing first the case number 1. So for case number 1, so if n, so meaning that's the function of the cosecant. Okay, so you only need to observe the cosecant function. So of course, if you will be trying to solve the problems later, of course you'll be also observing the cotangent function as well. But again, it will apply. The case will apply depending on the exponent. Okay, so in case number 1, if n, that's the exponent of the cosecant function. So if it's even and positive, okay, so if it's even and positive, so we need to factor out cosecant squared u du. So this is the factored out term. So again, anything that is factored out will be our probable value of our differential u for the u sub. So again, this will be our du. So again, that's still question mark because it could be negative du or du over 2 or 2 du. So that's so that will depend on the u sub technique process. So it may be du, it may be negative du, it may be du over 2, so on and so forth. So again, what we factored out is we'll be dealing with this value later once we reach the u sub technique. Okay, so we'll be dealing with what is left inside the integrand. So after factoring out cosecant squared u, so use cosecant squared u is equal to 1 plus cotangent squared u. So what does this mean? So if there's anything left, so since we factored out cosecant squared u, so meaning there's a cosecant squared term left inside the integrand. Okay, so for example later, so if we factor out cosecant squared, cosecant to the power of 4x, so it will become cosecant, so there will be 2 cosecant squared, right? So that will have, so this means that the other one is the factored out term, then the other one will be replaced by the Pythagorean identity, which is 1 plus cotangent squared u. Okay, so let me write this one. So replace the remaining. So remaining term is, so replace the remaining term with 1 plus cotangent squared u. So again, it must be cosecant squared u for you to be able to replace the value. Because again, we are using Pythagorean equations or Pythagorean identities. So that's for case number 1. So we're only observing the cosecant value, which is the n exponent. Okay, so let's try to solve the example. Okay, so let's try to write the process on the upper right. Okay, so again, so the n exponent in case number one, so it should be even and then positive. So next is we factor out cosecant squared u du, and then the remaining cosecant squared, or what is left of the factored out term, is we replace it by cosecant squared u is equal to 1 plus cotangent squared u. And then lastly is you're going to use u sub technique. So we have 4 steps. Okay, so again, looking at your exponent, so this is the cosecant function with an even and positive um, value. So meaning this one is already correct. So next is we try to factor out cosecant squared u du. So what will happen is we have cotangent cube for x, then cosecant. So getting 2 from the power of 4, so this will become cosecant squared of 4x. So let's try to enclose this one with the parenthesis so that we will know that this is the remaining value of your integrand. Then the factored out term is cosecant squared 4x dx. So this one is ready together with dx. So again, this is the factored out term. So step number 2 is done. So again, we need to replace, in step number 3, we need to replace the remaining cosecant squared u inside the integrand with 1 plus cotangent squared u. So as you can see, there's a remaining cosecant squared here. So we need to replace that one with 1 plus cotangent squared u. So placing a bracket so that we can identify the, the replaced value. So cotangent cube 4x. Then we have 1 plus cotangent squared 4x. Then bracket cosecant squared 4x dx. Okay, so next step is before we go to the u sub is we try to simplify the terms first inside the integrand or the remaining integrand. So let's multiply this one. So what you have is cotangent cube 4 of x plus cotangent squared of cotangent to the fifth. Cotangent to the fifth of 4x. Then we have the factored out term cosecant squared 4x dx. So let's try to underline this one so that this is the factored out term. Okay, so again, if we try to simplify further by arranging according to degree, so to the power of 5 should be the first term, then to the power of 3 should be the last term. So cotangent to the fifth of 4x plus cotangent cube of 4x cosecant squared 4x dx. Okay, so again, this is the factored out term, and this is the remaining integrand. So since it's already simplified and there's nothing else to do, so we now go to the u sub technique. So by using u sub, so again, the factored out term is our candidate for du. Okay, so question mark, because again, we don't know the exact value of our du. Okay, so as you can see, we need to achieve a derivative of cosecant squared for x dx. So in our derivatives, so we know that the derivative of cotangent is negative cosecant squared for x. So we let our u be cotangent for x. And then the derivative of which, so du. So again, that's negative cosecant squared for x times 4. So times 4 is, it came from the derivative of the angle. So that's why it has a times 4. Then dx. So we have negative 4 cosecant squared 4x dx. So as you can see, it's still not the exact value as the factored out term earlier. So we need to divide by negative 4. So you have negative du over 4 is equal to cosecant squared 4x dx. So meaning that the exact value for the factored out term is negative du all over 4. Okay, so this one is this term here. And then the terms inside the integrand, this will be u to the power of 5. This will be u to the power of 3. Okay. So by replacing the terms in the u parameter, so we now have the integral of u to the 5th plus u to the 3rd, then negative du all over 4. So factoring out negative 1/4, so negative 1/4, the integral of u to the power of 5 plus u cubed du. Okay, so now we can now integrate, because this one is already a basic formula. So don't forget to multiply negative 1/4 to each of the integrated terms. So first is negative 1/4, then you have u to the power of 6 all over 6, then negative 1/4 plus u cubed, that's negative 1/4 times u to the power of 4 all over 4 plus c. So you have negative u to the power of 6 all over 24 minus u to the power of 4 all over 16 plus c. Okay, so don't forget to bring back the value of the u parameter. So the final answer is negative cotangent to the 6 of 4x all over 24 minus cotangent to the 4th of 4x all over 16 plus C. So this is the final answer. Okay. So questions for this example. Okay, so I think there's no questions. Okay, there are no questions. So let's proceed with case number 2. So in case number 2, so earlier we looked at the exponent of the cosecant function. So if that particular case is not applicable, so we now observe the exponent of the cotangent function, which is the m. Okay, so if your n is not even, so of course the problem should have the other one be the case also. So m should be odd and positive integer. Okay, so next is we factor out. So factor out cosecant u, cotangent u. So again, this is the probable value for your du. So it's still question mark. So again, why this one is our du? Because again, if we recall our derivatives, so the derivative of your cosecant, okay, so derivative of cosecant x is negative cosecant x cotangent x. Okay, so that's why this is the probable candidate for, or the probable value for your derivative of u. And of course our u is the cosecant because this one will be giving us the value of the derivative that we need later. So next is if there's any remaining cotangent squared term, so we need to replace it with this identity, which is cosecant squared u minus 1. So replacing the remaining cotangent squared u term with this identity, which is cosecant squared u minus 1. So again, this formula is coming from 1 plus cotangent squared theta is equal to cosecant squared theta, and through manipulation by isolating cotangent squared u, so we have this equation. Okay, so let's proceed with the example. So again, let's try to write the steps first for case number 2. So m, again, that's the exponent of the cotangent function, should be odd and positive. So next is we need to factor out cosecant u, cotangent u, du. The next is we replace the remaining value for your cotangent function. So cotangent squared u by replacing it with this identity, that's cosecant squared u minus 1. And the next is u sub technique. So again, we have 4 steps to follow. So looking at your equation, so again, as what I've told you earlier, if we try to observe the cosecant function first, so this one is not even, but it is positive, but it's not even. It's a radical function. So we go to the other exponent, the exponent of the cotangent function. So since this one is in line with case number 2, it's odd and positive, so we need to follow the process of case number 2. So that's how you approach the different problems of your transformation by trigonometric functions. So you observe the two exponents. Okay. So next is, since we have an odd value for your cotangent function, so next step is we factor out this term, cosecant u, cotangent u. So parenthesis. So getting one cotangent. So getting one cotangent. So this becomes cotangent to the fourth of x. Then cosecant. So getting 1 from 4/3, getting 1 cosecant from 4/3. So this one becomes 1/3 of x. So you have cosecant x cotangent x dx. Okay. So you might wonder why I got 1/3. So of course, if you try to multiply this one again, so 1 plus 1/3. So again, this one. This will result to 4/3 still. Okay, then multiplying cotangent with cotangent to the fourth, this will result to cotangent to the fifth of x. So it still equates to the original equation. So nothing is being changed here. So just the appearance, but the equation is still balanced or still equal to the original equation. Okay. So next is we replace your cotangent squared u with cosecant squared u minus 1. So replacing cotangent squared with its identity. Okay, so notice that your cotangent function is to the power of 4. Okay, so meaning we need to apply this one twice, your step number 3. Okay, so bracket. Then we have cosecant squared u. Oops, mag-u na lang ko. So let's try to erase. So instead of u, this should be x. Minus 1. So again, since we need to apply this one twice, because it's to the power of 4, so squared. So cosecant squared x minus 1 squared. Then multiplied by cosecant to the 1/3 of x. And then bracket, then the factored out term, cosecant x cotangent x dx. Okay. So next is we need to expand this one. So let's try to underline first the factored out term so you won't be confused. Okay. So again, we are dealing with the remaining values in the integrand. Okay. The one in the parenthesis. So we need to expand the value of this term, this one, this term here. Okay. We need to expand this one for us to simplify it even further. So we have cosecant to the fourth of x minus 2 cosecant squared x plus 1, then multiplied by cosecant to the 1/3 of x, and then the factored out term earlier, cosecant x, cotangent x, dx. Okay, so next is we distribute. So distribute or multiply cosecant 1/3 to each of the term inside the parenthesis. Okay, so we now have cosecant. So 4 plus 1/3. So that's 13 all over 3 of x. Okay, so try adding that one later. Or if you want to review this one later, so of course, you should be quick in adding fractions. So minus 2. So cosecant, so 2 plus 1/3, that's 7/3 of x. Then the last term is, so multiplied by 1, so we have the, the same value, 1/3 of x. So cosecant x, cotangent x, dx. Okay, so since there's no simplification process left inside the integrand, so we can now proceed with the u sub. So again, if you observe the remaining integrand inside the parenthesis, so there's nothing else to simplify or to expand. Okay, so we now proceed to u sub. So again, this one is our candidate or the probable value for your du. Okay, so question mark. So again, as what I have told you earlier from the previous slide, so since this one is our derivative, so coming from our calculus 1, so we know that the derivative of your cosecant x is negative cosecant x cotangent x dx, right? So for this one to be exactly the same as the factored out term earlier, so we need to divide by negative 1. So negative du is equal to cosecant x cotangent x dx. So our exact value for your du is negative du. Okay, so this one is negative du. And then this one is u to the 13 over 3, u to the 7/3, u to the 1/3. Okay, so by replacing or by or by substituting the different values of your u, so we now have u to the 13 over 3 minus 2 u 7/3 plus u to the 1/3, then negative du. So getting the negative outside the integral symbol, so that's negative u to the 13 over 3 minus 2u 7/3 plus u to the 1/3 du. Okay, so now as we integrate, so again, don't forget to distribute the negative sign to each of the integrated terms. Okay, so let me write it here first so that we can have space. So the first term is negative, so u to the, so 13 over 3 plus 1, so that will be 16 all over 3 all over 16 all over 3. So minus 2. So let's try to write this one. So minus the negative 2. Okay. So u to the 10 thirds. So 7 thirds plus 1, that's 10 thirds. Then minus plus, so that's minus still. So we have u to the 4 thirds all over 4 thirds plus c. So simplifying is we have u, so 3 u 16 over 3 all over 16. So this is minus. Then plus, so plus 3 u 10 thirds all over 5. So it's 5 because we cancel out 2 here and 10 on the denominator. And 3 u to the 4 thirds all over 4 plus c. So replacing it with the value of your u parameter, so the final answer is negative 3 cosecant of 16 to the power of 16 over 3 x all over 16 plus 3 cosecant 10 thirds x over 5. So minus 3 cosecant 4 thirds of x all over 4 plus c. So this is your final answer. Okay, so do you have questions or clarifications? Sorry. Hello? So do you have questions? Okay.